For today's objective, we are going to discover meltable materials. So let's get started. What does it mean to melt? To melt means to become liquefied by heat. So the easiest example of this, maybe the first thing that popped into your brain when you thought of something that can melt, is ice. Ice melts when it gets too hot. Ice has the property of being meltable. So water is the liquid form of ice, and ice is the solid form of water. When it's a liquid form, it can take the shape of the container that it is poured into. So when you pour water into this ice tray, and the ice is going to cool and solidify, it's going to come in the shape of rectangles. Now, what's so special about liquids is that, just to reiterate, they can take the shape of any container they are poured into. So it doesn't just have to be a rectangle ice tray. It could be in the shape of animals. It could be in the shape of any mold. So this one, here's some monster molds, some Pac-Man molds, the states. Okay, you can pour water into any of these molds, and when it cools and hardens and turns into ice, it'll take the shape of its container. And this can benefit us also in the form of popsicles. Okay, solidified frozen ice that has been shaped. So something that's key to know about meltable materials is that different materials have different melting points. So for example, it doesn't take much for an ice cube to melt. You take it out of the freezer, you put it in your hand, it's going to start melting almost right away. Whereas different materials need it to be much hotter for it to melt. Like this duck. So this right here is plastic. Plastic is another material that has a meltable property. It can melt. So what do we just learn this means? It means when plastic gets hot enough, it can turn into a liquid. And once it turns into a liquid, we can mold it into different shapes because liquids fit the mold of their container. So if I take a melted plastic, I can turn it into Legos. I can turn it into dolls. I can turn it into dinosaurs. Basically, you can turn it into anything. Any mold you can think of, you can liquefy plastic, put it in that mold, let it harden until it becomes the solid toy of your choice. In fact, before we had plastic toys, we had wooden toys, material that does not melt. So whenever you had to make a toy out of wood, you had to carve it carefully, painstakingly, and you had to do that for every single toy. But when they invented plastic, they could just melt down the plastic and replicate it really easily by just filling molds and get a lot of toys on the shelves like that. Okay, let's take a look at metal. So metal is a material that is meltable. So there's so many different kinds of metals that each metal has a slightly different melting point. For example, aluminum, that melting point is 660 degrees Celsius. But gold, another kind of metal, it needs to heat up to over 1,000 degrees Celsius to melt. Okay, but once again, once you get metal in its liquid form, you can put it in a mold and it can harden into solid shapes of your choice. So some examples, we have metal cookie cutters, coins, keys, jewelry. Another material that is meltable is glass. So glass has an even higher melting point than some metals out there. So the glass melting point is 1400 degrees Celsius. So you take a solid, you get it hot enough, you can melt it into its liquid form, and then cool it into different shapes. So of course, there's different shapes of drinking glasses. You probably have a variety of these in your own homes. And then there's an art called glass blowing, where you can once you melt the glass, you can use different tools and twist it into various shapes of your choice. And once it's hard, you get different glass art pieces. So you can do this with practical art pieces like vases, it looks like here. And then over here, this is a glass chandelier that has been created by melting it down and hardening it as it cools. So in conclusion, another property we learned about today is if materials are meltable or not. All meltable materials melt at different temperatures. So ice has a much lower melting temperature than something like metal or glass or plastic. This property is useful because you can heat a substance, melt it, pour the liquid into any mold, and let it cool and harden again to make into different shapes. For you all is to think of any other materials with this property meaning anything else that melts. Can you think of anything you eat that melts? Okay, think about it and let me know what you come up with on Seesaw. I'll provide some answers for you on the grid of things that I thought of.